Thank you. It's a pleasure to be here. This is my first time in the Maritimes. I was introduced as a professor at the University of Waterloo. I also run the Cybersecurity and Privacy Center at Waterloo. So I'm also here to learn from Ali how to run a great cybersecurity center. But today I'm going to talk about a topic that I myself and many of my colleagues at Waterloo are working on. Can we trust AI-based systems? So you'll notice that my name is spelled without a first name. That's because not everything is standardized in the world. So my last name is also my given name. So regardless of what my name tag says, just call me Asokan. Right, so can we trust AI-based systems? So briefly, I'm going to talk about what are the challenges in making AI-based systems trustworthy. And then if I have time, I'll also talk about a specific technical aspect that anybody who is deploying protection mechanisms for AI-based systems should think about. So why do we even talk about this topic? Why do we have to care about AI-based systems and making them trustworthy? So here is a chart that shows the North American market cap for AI-based systems. And I could have picked anything, not just the North American market cap. I could have picked the investment in research. I could have picked the number of startups. They all would look the same. There's an exponential growth, right? So I'm sure all of you would agree that AI is going to be pervasive. And we already heard, like the previous speaker, John Martin, talked about healthcare and so on. So it's not just going to be pervasive in terms of investments and so on, but also in terms of the different aspects of human life and work and play that the AI is going to affect. So you've seen that AI is going to be used in precision medicine. AI is going to be used in law enforcement, in recruiting. People use AI to predict whether a particular candidate is going to stick with the company or not. And of course, cybersecurity. Cybersecurity has a tradition. I think Ali is a pioneer in this, using AI for intrusion detection and so on. So whenever a technology is so successful, it also attracts bad actors. And we have seen that again and again, right? We have seen that with software as a whole. We have seen that with internet. We will see with other things like blockchains, and AI is no exception. So what do bad actors do? They try to subvert the system in some way to meet their own ends. Maybe it's profit, maybe it's undermining somebody else's initiatives, but it's a given that bad actors will be attracted. So if you have been working in this area, you may have seen some of the examples that I'm going to give. So initially, I'll start with security concerns and privacy concerns, right? So what can bad actors do that affect the security and privacy of AI-based systems? So here is an example that some of you may have seen. There are machine learning. So I'm going to talk about one kind of AI, which is called machine learning. There are machine learning classifiers that, given an image, can tell you what kind of object is in that image, right? So if I show this, all of you as humans would say it's a school bus, and a state-of-the-art machine learning image classifier would do the same. Now, if I add a little bit of noise, all of you as humans would still recognize this as a school bus, but the state-of-the-art image classifier would be completely fooled. So in this case, this is an example from several years ago when researchers sort of first alerted to this problem. The state-of-the-art classifier at that time would think that this is an ostrich. When you come to think about it, this is not surprising, right? So all of you know about optical illusions. Optical illusions are fooling your brain, right? So your brain is a kind of like a machine learning model, and it can be fooled. So the fact that machine learning models, based on software, can be fooled is fundamentally not a surprise, but it is a concern, right? So initially, when this was announced or introduced, people thought of it as a curiosity. But then there have been subsequent works that showed that this is actually a robust, the ability to evade a machine learning model that does image classification is robust. So here is an example of again, a similar kind of thing. So there's a picture of a cat. The machine learning model will classify this as a desktop computer. But this classification is robust in the sense of like twisting, turning, zooming in, and even if there's a kind of a video, right? So you see that the machine learning model is consistently classifying this as a desktop computer. So again, you could think that, no, this may be just a curiosity, But you can imagine, like, think about autonomous driving. A self-driving car essentially has a model like this that takes images of what it sees, looks at street signs, traffic signs, and so on, and then try to interpret them. If an attacker can make small modifications to a traffic sign, that can have disastrous consequences. And it has in fact been shown. It's not just images. 1,
2, 3, 4, 5, 6, 7, 8, 9,
so this is Siri. You all know that you can give voice commands to Siri. These researchers showed that you can fool Siri by giving an ultrasound command so that a human wouldn't hear it as a command. But you can see that a locked device will unlock and fall when they play ultrasound. So the ability to evade a machine learning classifier is not limited to images. Images and audio classifiers, classifiers that look for malware, intrusion detection, all of these are vulnerable. So let's take a step back. How do we go about finding systematically all the problems that can occur in machine learning-based systems? Because that's a prerequisite for trusting these systems. So I'm a system security researcher. The way we think about identifying problems is to think about, go about in a systematic way. So let's take machine learning in general, right? So usually there is some data that's collected from data owners. That's called your data set. Then there's an analyst who trains a model, a machine learning or AI model using this data set, using some off-the-shelf software, probably with some external libraries, and that results in a machine learning model. And then the machine learning model is made available to clients via some kind of an interface, a prediction service provider API. This may be behind a firewall. It may be a cloud-hosted model. So think about Google Translate. Google has spent a lot of time training their translation model. That's not given to you. That's sitting on Google Cloud. And you have an API, either using their browser front end or a programmable API, right? And the client is supposed to interact with this model via the API. Now think about who are the potential adversaries? What are their targets? If you can do this systematically, I claim that you can sort of lay out all the machine learning security and privacy problems. So I'll give you some examples of how this process might work. So the example I gave you, fooling a machine learning model, that's actually an attack on the integrity of a model. You want to make the model, so it's not about confidentiality, we want to make the model behave incorrectly, right? And the adversary is now on this side of the prediction API, and they are doing something like manipulating the traffic sign. And their goal is the target is this output of the model, right? So by manipulating the traffic sign, if you can fool the model into thinking that it's a stop sign, it's a speed limit sign, that can be disastrous. So again, this was discovered like several years ago, and that's sort of one kind of problem. The second kind of problem may be privacy of training data, right? So people contribute data. Joel talked about medical data where the data itself is sensitive. So now the target of the attacker, who is still on the far side of the prediction API, is to learn about the people who contributed data. And they can do that by essentially making repeated queries to the machine learning model via this official API, and then use that to learn something about the training data. So there have been different kinds of ways in which you can learn, or different types of information that you can learn about the training data. People talk about membership inference, seeing if, like, Ali's data was used in a particular medical diagnosis model, or inverting the model. Like if you have a face recognition system that gives access to a building, by inverting the model, we can see sort of average representations of each person's face. If a person's face were used 100 times, you could still see whose faces were used to train the model. So that's about training data privacy. I'll give one more example, which is model confidentiality. So again, this time, I'll give you two more examples. The adversary is still here, but the target of the adversary is now the model itself, right? So the legitimate users are allowed to ask questions from the model, right? They send queries, you send a piece of text that you want to translate to Google Translate, Google gives you a response. By using, every time you ask a question like this, the model leaks some information. So if you do this enough times, you can build what's called a surrogate model, which is in some level similar to the original model. That's called model extraction. And this is something my students have been working on. So the text that you see in blue are pieces of work that my students have done. And you can imagine that companies that invest a lot of money to train models and want to monetize them are very concerned about model extraction. If somebody can steal the model without actually spending that effort. Like I said, I'll give one more example. And there are more examples in the slide deck, which you can find on my webpage. But I hope this sort of gives you an idea of the kinds of different problems that may exist. So the last example I want to give is profiling, right? So this time, the adversary is not on the far side. The adversary is the entity that's holding the model, right? So if Google is holding the Google Translate model, Google itself may be malicious. So what might they be interested in? They might be interested in profiling the user. Maybe because of advertising, maybe because of whatever other purposes. So here is an example where, let's say, the model is for detecting malware. So every time you install a mobile application, you want to see if that's potentially malware. Think about how it worked like a decade ago. A decade ago, we had an antivirus client on your mobile phone or on your PC. And from time to time, it'll get an update of threat databases from the antivirus provider, but all checks were done locally. If you install an application, nobody else finds out whether you install an application. Now, for all very good reasons, these kinds of models are moving to the cloud because the cloud has elasticity, the cloud can have sort of up-to-date databases and so on. So now every time you install something, you're actually asking the cloud, I'm installing this app, is it potentially malicious? So in other words, the malicious model provider or the machine that's running the model finds out the set of applications that you have on your device. And there have been enough works that have shown that if you tell me what applications you have on your mobile device, I can profile you. I can tell your gender, I can tell your income, I can tell your political beliefs, your religious beliefs, all of these things, right? So that's a violation of this user's privacy. So how can we still use a cloud-based model for whatever good purposes that we're interested in without letting them profile users in this way? So again, there have been a number of works that allows the possibility of doing that efficiently. So I'm going to skip the other examples, but I'm going to go to the a third concern. So until now, I've talked about malicious actors who are interested in compromising security or privacy. And you can ask, is this the only concern in getting us to the point where we can trust AI-based systems and AI, machine learning-based systems? So what if the entity that's running the model is not malicious and none of the players in the system are malicious? Is there still a problem? You know that whenever someone asks a rhetorical question like this, the answer is always yes, there is a problem. And that problem is fairness. So about a couple of years ago, some people noticed that Twitter, whenever you post an image to a Twitter decides sort of which part of the image to highlight as a preview. So if you have a large image, Twitter chooses which image to show to the readers of the Twitter post. And someone noticed that if you had a picture like this, consisting of two faces, one the US Senate Republican leader, and the other one is the former president, Twitter consistently picked one image to preview. And you can imagine which image it was. And that's a question of fairness, right? So if there are two images and the Twitter always was biased towards one image, that's a question of fairness. And here, this may be an amusing example, but fairness can be a serious concern when it comes to other uses of AI-based models. People are using AI models for predictive policing, right? Or in jurisprudence, or deciding who gets parole. And if the models are biased like this, that it sort of makes one decision overwhelmingly for some kind of subgroups, maybe based on gender, maybe based on race, that's a big concern. And so part of it is because the training data may be biased. And if training data is biased, then everything that you train from that is also biased. But it's not only that. So Twitter, when this was pointed out, somebody noticed that this is not just for images of people's faces, but also for other things like cartoon characters. So here were 2 images, and Twitter always picked this one image as the preview. And Twitter knew about this, and they actually posted a message saying that we were aware of, or we were concerned about fairness issues. We trained extensively, but still, they were not able to protect the model, protect the machine learning model that chooses the preview so that it wasn't biased. And the reason for this is that modern machine learning models are like black boxes. Nobody understands exactly what goes on inside them. And people use the term interpretability or explainability to refer to this phenomenon of not being able to explain why a model makes a decision that it does. And you can imagine that that's a serious fairness concern, right? If these models are going to be used to make decisions that affects the lives of people, and we don't know exactly why the machine made that decision, that can have serious concerns. So I would say that security, privacy, and fairness are 3 aspects that would go towards making machine learning models trustworthy. The positive thing is that there's a lot of research in this area. Like I said, myself and many of my colleagues and people around the world are working on not only how to use machine learning for cybersecurity and privacy problems, but also the inherent cybersecurity, privacy, and fairness problems of machine learning themselves. So the positive news is that trustworthy machine learning is an active research area. But I want to sort of point out one issue that many researchers working in this area haven't still sort of come to recognize. And that is that most researchers, including my group and my students in the past, have only focused on one problem. So a lot of my students have been working on the model extraction problem. So we try to understand how can an attacker steal a model, and then how can we make our models robust so that stealing is either prevented or disincentivized. And this is common. There are people who work on privacy, there are people who work on poisoning, there are people who work on model evasion. But think about a company that wants to deploy a model, right? They're not interested in a single issue. They want a model that's deployed, that is resistant to stealing, that cannot be evaded so easily, that cannot be poisoned so easily, that is fair. So all of these different solutions have to be deployed and be effective simultaneously. And this is something that hasn't received enough attention. So I don't have time to talk about this today. Tomorrow I'm going to be giving a keynote in the research part of PST, and I'll go a little bit more into that. So we did some investigation looking at model ownership verification. Like, how do I prove that somebody, if somebody stole my model, how can I prove that it's my model? That'll be a way to deter model stealing. And there are different techniques for model ownership verification. We looked at how do these techniques interact with other techniques that solve other problems, such as differential privacy or adversarial training. And the sort of short preview is that quite often they conflict. If you want to protect against 2 concerns, you might end up protecting one of them completely inadequately. And we just touched a small slice of these conflicts, but this picture gives you an idea of the kinds of security and privacy concerns that are in machine learning models. And there are whole swaths of this space where conflicts haven't been adequately studied. So I will conclude at this point. So I hope I have convinced you that one, machine learning and AI is being broadly and widely deployed. And 2, there are serious security, privacy, and fairness concerns. And to be able to engender trust in these AI models, we need to address these concerns. And this is done systematically by thinking about this potentially adversarial behavior, and adversarial behavior in a broad sense, right? So I talked about fairness, where there is no specific malicious entity, but you might still end up with an adversarial end result. The good news is that this is something that's actively being researched. And I think many of the previous speakers have pointed out that you shouldn't only think about the good things that can come out of a technology, you should also think about security and privacy right from the outset. I think one of them said, are we sleepwalking into a problem? And with AI-based system, I think we are in that stage where we run the risk of sleepwalking into widespread deployment of AI. So this is the right time to address these questions. And once you think about deploying these solutions, you also have to worry about practical considerations that academics might not be aware of or conscious of when they start researching some interesting problems, such as simultaneous deployment. So if you're interested in more about the other types of security privacy problems in machine learning that we are looking at, I leave a link there. At this point, as a professor, I know that if I say, ask me any questions, nobody asks. So I can also point to some of you and make you ask questions. But I think that we have a volunteer.
Hello, this is Tarek from KPMG. So some of the data that's used to train the models is open source. Have you seen any campaigns or any coordinated efforts to poison open source data that's used for training, to kind of poison it in advance of using it? So
there are standard data sets. I haven't seen any particular attempt to poison those standard data sets like ImageNet and so on. But there have been cases, like real life cases, where poisoning has happened. A good example is Microsoft Tay. I hope there is nobody from Microsoft here who might be offended by what I'm going to say. Microsoft deployed a chatbot called Tay 2-3 years ago. And so chatbots are very popular, right? Chatbots can be useful in customer support and so on, where they try to understand natural language queries that people send to the bot, and then give useful answers. So Tay was a Microsoft research chatbot that was deployed. And over a weekend, and so Tay was also learning online. So it wasn't not just trained with a particular data set, but by interacting with users, it will become smarter and smarter, just like any other machine learning model that learns online. So during the course of one weekend, people who interacted with Tay via Twitter, I believe, essentially turned that into a Holocaust denier. Right, so they turned Tay so that it started spewing out messages that are in the direction of denying that the Holocaust ever happened, which ultimately forced Microsoft to take it offline. So that's a concrete instance where I know poisoning of data has happened, even though it's not a data set, it's an online training.
Hi, I'm Laura Oblinus, and I'm representing the New Brunswick Cybersecurity Ecosystem Consortium. And so question for you on the supercluster. So I'm assuming that you're involved with the AI supercluster, being in such close proximity to the Waterloo-Toronto corridor. Curious what the advantage has been in the establishment of that supercluster in terms of what some of the impacts or results that we've seen and the investments that have been made both from the public and private sector. And how much of the work that's being done is sort of forward thinking, looking to the future in terms of where we want to go, and how much of that is related to real-time problem solving for applying it to industry today?
I have to apologize. The short answer is I don't really know. I'm relatively new to Canada, so I'm still grappling with understanding the ecosystem. This is one of the things that I'm hoping to learn from somebody like Ali, who knows the systems inside out. I know that there are researchers in Waterloo who have been involved in, Waterloo has an AI center as well, who have been involved in the superclusters, but offhand, I don't really know. So sorry for that.
No problem. So I'll ask another question then. So from the work that you're doing in AI, what would be an example from a critical infrastructure perspective? Here in New Brunswick, we're quite strong on critical infrastructure protection. And so could you give us an example of some of the work that you're doing in AI and how that may apply or be helpful in looking ahead to the future on the critical infrastructure protection side?
Right. So that's a very interesting question. Thank you for that. So different people I talk to are interested in different problems that I talked about. So I said, take a machine learning model and think about systematically all the different problems that could occur. So for example, privacy advocates are worried about privacy, whereas industry partners that we talk to are worried about model extraction. Many industry partners are not so worried about this model evasion that I told you about, right? So changing the input or twiddling with the input to fool a machine learning model. I think that would be a serious concern in critical infrastructure. For example, I mean, you could think about authentication that's used in access to critical infrastructure, right? So face recognition, yesterday we saw multiple kinds of authentication that are used to control access to a building with high security needs. People have shown that by manipulating the input in subtle ways so that a human guard that's standing next to watching you trying to enter a building might not recognize that you have made these minor changes to input. Maybe you are wearing glasses with particular perturbations, or maybe you wore some makeup or whatever that might be not suspicious to a human guard, but it can completely fool a face authentication system. That's an example that I can think of where, like I said, industry aren't that worried about this now, but from a critical infrastructure perspective would be crucial.
Great, thank you.
Great presentation. John Ferguson from the Canadian Internet Registration Authority. Just a question, a lot of what we look at is Canadian data, Canadian landscape. One concern with some of the machine learning data is it's often community sourced, comes from different jurisdictions. How much of your work is like looking at models that are Canadian specific and managing the inputs to that actual algorithm?
So in my own personal work, many machine learning researchers or machine learning security researchers do use standard data sets, public data sets that are available, for the reason that actually getting access to data sets is the biggest problem in machine learning research. Having said that, I think there are, especially when it comes to privacy, there are locally specific data sets that would be important, right? So imagine like hospital districts having data that's sourced from the residents of an area, and then using that to train diagnostic models that have local relevance. So the data regulations would dictate that this data cannot leave jurisdictions, and you still need to be able to make models that are robust and have good performance. So I myself haven't worked with this kind of data, but I can imagine that balancing confidentiality of data while achieving good model performance is a concern. I think Joel mentioned federated learning. Federated learning, just to make it clear, is not a solution for privacy, right? So that doesn't show enough times that just by federating learning, you can't protect the confidentiality of the data, but it can be one defense among many in coming up with good models while keeping data local to where they are. I'm not sure if I answered the question, but if not, we can also talk offline. Thank you.